France, more than 110 terawatt-hour of waste heat is produced by the industry. This represents 36% of fuel consumption of the same sector. And half of this heat is above 100 degrees. In the context of climate change and global crises, such waste is unacceptable. Alternatives exist, but they are not sufficient. So we looked at another way to solve this problem, the alternative of biomimicry.
We are a group of 7 students from University of Louvain in the digital specialty of your master's degree in geology. In order to optimize the recovery of waste heat, we will inspire by pre-existing models to improve the contact of fluids in the context of the heat exchanger, the typical architecture of the pine cone.
Our method is structured as follows. First, a study of the pine cone covering state-of-the-art 3D modeling and simulation, then a design and modeling of common and bio-inspired exchangers, and finally digital simulation to validate the use of bio-inspiration.
The pine cone is constructed according to the Fibonacci sequence. Its scales are arranged to allow the formation of turbulence in them. There's maximal contact between the air and air eggs, increasing the chance of fertilization. Parametric modeling and simulations on X-flow made it possible to highlight them and confirm our bibliographic study.
Following this observation, we conceptualized a heat exchanger model that uses pine cone cell structure. Improve the turbulences would optimize the heat transfer between the fluids. We created this model using generative design. To test our model, we also took a common heat exchanger model to compare the efficiency of both.
So several simulations show that on the aspired bio model, the heat exchange was quicker, and the temperature of the structure quickly reached that of the heating fluid. Several simulations also demonstrated that the slower the fluid is, the more efficient the heat transmission is.
In conclusion, our bio-inspired model is more efficient than current pre-existing solutions. With this technology, we can now reuse industrial emissions to create heat without consuming any fuels. In an increasingly modern and digital world, the simplest solutions are just in front of us.